Hey everyone, how's it going? In this video, we're going to be solving this LeetCode problem 54 spiral matrix. Given an m cross n matrix, all we need to do is return the elements in the matrix in spiral order. So the elements given to us are 1, 2, 3, 4, 5, 6 and 7, 8, 9. And we have to return these elements in the spiral order. That is, we will start from the top left. That is, we will start from 1. Then we will go to 2. Then we will go to 3, and from 3 we cannot go to the right anymore. So what we will do is we will go down, then again we will go down, and from 9 we cannot go down anymore because there are no more elements. So what we will do is we will go left to 8, then again left to 7, then up to 4, and from 4 we can again go up to 1, but 1 has already been processed at first. So what we will do is we will go to 5. Now the most efficient way to solve this problem is also the easiest way. Let's get into the drawing explanation of the problem. Alright, we have this matrix 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And what we will do is we will start from the top left part of the matrix. That is, we will start from 1, then we will go to 2, then we will go to 3, then we will go to 4. And from 4 we will go down to 8, then down to 12, and like this we will solve the problem to 11, to 10, to 9, to 5. And now see one thing, what we did here, we took this outermost part of the matrix, and then what we did here is we shrinked it to only 2 elements remaining. Now we can again run the algorithm on these 2 elements and find out our solution. Let's run through the algorithm now. What we will do is we will have a left pointer, a right pointer, a top pointer and a bottom pointer. Now see here, I have taken the right pointer, one positive one, to the right side of the entire matrix. Okay, I am doing this just to make the code a little bit easier, and also for the bottom pointer I have did the same. Now what we will do is we will start from the top left part of the array and we will traverse. Okay, we will traverse to the right. So what we will do is we will start from 1, then we will go to 2, then we will go to 3, then we will go to 4. Now notice one thing, after completion of this part of the array, we can have an output of something like 1, 2, 3 and 4. We can have something like 1, 2, 3 and 4. And what we can do is, then the topmost part of the submatrix has already been traversed and completed. Now what we can do is we have to traverse only this part of the array. So can we not do something like we can increment the top by 1? Can we not do that? Think of it. Can we not do that? We have already traversed this part of the array and now we have this part left. Can we not traverse the same using the same algorithm? Can we not traverse this part of the array? Yes, we can. Now from 4 what we can do is we have to go down to 8, again down to 12. Now this column of the submatrix has been processed. Now what we can do is we can have this right pointer move one bit closer to the left pointer. We can have the right pointer here. Now see, we have shrinked again this part of the array. Again. Now what we have here is 8 and 12. Now what we will do is we will go left because there are no more elements down to 12, so we will go left. So we will go 12 to 11 to 10 to 9, and see now what we did here is we have 11, we have 10 and we have 9. Now see, what we have here is we have processed this part of the array. So can we not decrement the bottom pointer by 1? We can. So now the bottom pointer is at here, that is 5, 6 and 7. Only this part of the array. We have this part of the array left. we have this part of the array left. So what we can do here is we have to go up. We can go up. We have processed the 5. We processed the 5, and now see, we have all completed this part of the array also, this part of the array also. And now what we can do here is, since we have completed this part of the array, we can have the left pointer pointing to, we can move the left pointer by 1, and our right pointer has already been processed and it is here. So now what we can do here is, again we can start the same algorithm from the top left part of the sub array. That is, we can start again our algorithm from 6, and then again we will go right to 7, and then like this we can process the entire array. Okay, so this is our answer. I hope you get the drawing solution. This has become a mess, but anyways, let's write the code. Okay, so for the coding solution, let's have a array list of integers. Result equals to new array list integer int. Now we will have the pointers. Left is pointing to the 0th column, right will be pointing to the end of the column of matrix. Our top would point to the first row, and our bottom will point to the last row. I am not doing -1 here. I am not doing -1 here because I already told you that I have something like, I first started with the right pointer at here, at the end of an array. Okay, that is because just to make the code a little bit simpler. That is why I am doing that. So now bottom would be matrix dot length, and now what we will do is we will traverse through the matrix. While left is less than right and top is less than bottom, we will traverse through the array. Now at first we will get every element, every I in the topmost row. So for int I equals to left, I is less than right, I plus plus, we would add to our resultant array. Okay, so matrix, the topmost row and the ith column, we will get every element for that. Okay, now after completion, what we will do is we will increment top by 1. As you saw, we completed this part, we completed this row, and we incremented top by 1. Now what we will do is we will get every I in the rightmost column, in the rightmost column. For int I equals to top, I is less than bottom, I plus plus is dot add matrix I and right -1, and then we will do right minus. Okay, now what we will do is we will go down, we will go left. Okay, we will go left. So what we will do is we will check, first we will check if top is less than bottom. Now if you don't understand why top is less than bottom and left is less than right, I am going to do that. Check for the arrays, single arrays 1 2 3 and again check for 1 2 3. Check for these two test cases and you will get it why I am doing this check. Okay, now if top is less than bottom, we will traverse left. For int I equals to right -1, we would get every I in the left part, in the bottom part, sorry, in the bottommost row. So we will do I minus res dot add matrix bottom -1 and I, and again we will check if left is less than right, then we would for loop int I equals to bottom -1, I is greater than equals to top, and I minus we would do res dot add matrix I and left. Now we would do, at the end we would do left plus plus, and here we have to do bottom minus, and at the end we would return our result. Okay, okay, it runs, and let's submit the code now. It submits and the runtime is 0 ms. If you like this video, please like and subscribe, and if you have any suggestions on how I can improve the quality of these videos by editing, then please drop a comment in the comment section, and I will see you in the next video. Bye.